Class, this is our Friday on our third week, which is for April 17th, and this is the end of chapter 13. And this starts on page 597. Now what I've done is recreated the picture in the book as best I can, and you see this is the graph of what's called the normal distribution. So if you'll notice, right in the middle on the bottom, which would be the x-axis, is 500, that's the mean, and then the standard deviation is marked off by 100 to the right to 600, another 100 to the right 700, and another 100 to the right 800. So 600 is one deviation to the right of the mean, 700 is two standard deviations, 800 is three standard deviations, and then from 500 we go backward. 400 is minus one standard, 300 is minus two standard, and 200 is minus three standard deviations from the mean. Now I've put in the height of the rectangles above them so that we can count the percentages, or how much out of 100 is being used for each part that they're asking us. So the graph illustrates the scores of 100 students on a standardized test. This is normally what you've heard of as grading on the curve. So find the percentages of students with scores in each interval. From 500 to 600, that would give us the right rectangle of 19 plus the triangle of 15. So that would be 34 over the total 100, or 0.34, which is 34%. From 300 to 400, you'll notice we have the rectangle that's 4 high, plus the right, the rectangle that's 10 high. So that's 14 over 100, 0.14, or 14%. Now from 300 all the way to 700 is going to be double the amount from 300 to 500, because it's symmetrical. The same amount on the left is on the right. So we'll look on the left. We're going to count 300, the rectangle starting at 300, which is 4, the next one to the right 10, plus 15, plus 19, and we're going to double that because we have the same on the right going down to 700. So we're going to have 2 times 4 plus 10 plus 15 plus 19, which is 2 times 48, or 96 over 100, 0.96, or 96%. Now here we're going to show you what's called the percentages for plus or minus the standard deviation. Now notice in the middle is got two 34% areas on either side of the middle, and that's the mean, and it goes from negative 1 standard deviation to 1 standard deviation, which is 68% of the curve, which is the two 34s. Now if we go out another standard deviation to the left and another to the right, the next triangle or area out from the right of 34 is 13.5, and on the left side to the left of 34 is 13.5. So to the 68 we're adding twice 13.5, or 68 plus 27 is 95%. And that's the number used most in taking areas plus or minus 2 standard deviations. Now if we go out to plus or minus 3, that little bit of the curve from negative 3 to negative 2 standard deviations is 2.35, and on the right hand side the comparable 2 to 3 is 2.35. So when we add that to the 95, those two, we get 99.7. Notice there's the tiniest bit, 0.15%, to the right of 3% and to the left of negative 3%. Okay, now in example 2, we want to say that the middle 95% is between 2 standard deviations to the left of, notice, the mean is 100, the middle is 100, the spacing for the marks is 15, so 100 minus 2 15s is 70, and 100 plus 2 15s is 130. So the middle 95% is from 70 to 30. And now what percent of the data lies between 85, which is minus 1 standard deviation, and 145, which is 3 standard deviations? So we'd have to the left of the middle the 34% from 85 to 100, then the right side 34%, then the 13.5, and then the 2.35, which we add up all together, and it actually comes out to a little bit less than 84.84, but we'll round it to 84%. And what percentage is greater than 115? Well, now that's, instead of adding all the little numbers, we can take it as the whole right side minus the amount from 100 to 115, which is what we don't want. We want the amount greater than that. So the whole right side minus 34 gives us the amount greater than 115, which turns out to 16%. Now another thing commonly used with the standard curve, the normal curve, is the z-score, which is the number of standard deviations from the mean, which we've already really dealt with. And its formula is z equals the number minus the mean, that little u with the leg on the left, over the standard deviation. So we're using the same numbers from example 2. So 145 is got a z number of 145 minus the mean 100 over 15, the standard deviation, or 45 over 15, which is 3, which we already saw. Now 130 has a z-score of 2 because it's 130 minus 100 over 15, 30 over 15, or 2. And 115 has a z-score of 1 because it's 100 plus 15, or using the z-score, 115 minus 100 is 15 over 15 equals 1 standard deviation. Now 55 is out minus 1, 2, 3 there. So 55 minus 100 over 15 is minus 45 over 15, or negative 3. And coming up to 70, we know it's negative 2 because 70 minus the mean 100 over 15 is negative 30 over 15, or negative 2. And now coming up to 85, which we know is negative 1, comes from the z-score calculation of 85 minus 100 over 15 is minus 15 over 15 equals negative 1. So the marks, when you draw a standard normal curve, you have the mean in the middle, which has the z-score of 1, and then you count off 3 standard deviations to the right and 3 standard deviations to the left, which is the same as going from a z-score of negative 3 to a z-score of positive 3. And that has 99.7% of the area under the curve, as we've already seen. Okay, now the homework starts on page 600, and it's only going to go out to, it's going to go out to the regular 26. So, draw a normal distribution and use it to determine the percent of the data that falls within each interval. Now, we've already done this and labeled it. So, problem 2, the amount of area from mean minus 2 standard deviations to mean plus 2 standard deviations is the 234s around the middle, and the 213.5s, as we said, add up to 68 plus 27 is the 95, the most commonly used one. Now from problem 4, the mean minus 1 standard deviation to the mean plus 2 standard deviations is the 34 to the left of the mean plus the 34 to the right of the mean plus 13.5 to the right of that, which adds up to 81.5%. Now mean minus 3 to mean minus 1 standard is the 2.35 plus 13.5, which adds up to 15.85, not as much. Now when we say more than the mean minus 1, we're taking the 34 to the left of the mean plus the whole right side. We don't have to add up all the pieces. We can just say the whole right side because it's greater than mean minus 1 sigma. So that's 34 plus 50 is 84%. Now below 50 is just the left half, which would be 50% again. And above 55, we'd already done this, is the whole right half minus the area from 50 to 55, which is not wanted, so we can say that's 50 minus 34, or 16. And now, on 14, we're going from 35, which is 3 standard deviations below, to 45, which is 1 standard deviation below, which we've done before as 2.35 plus 13.5, or 15.85% under the curve. Now above 40 is above mean minus 2 standard deviations. So on the leftmost one between 40 and 45 is 13.5, then next is 34, then next is the whole right half. So that all adds up to 97.5. Okay, now we're going to start doing some z-scores. If they give us a mean of 21 and a standard deviation of 5.3, find the z-scores for 10.4 to 26.3. So using our z-score calculation, z is the big number 26.3 minus 21 over 5.3, which conveniently for us is 5.3 over 5.3, or 1. So the high number has a z-score of 1. The low number is 10.4 minus 21 over 5.3, which is negative 10.6 over 5.3, which again conveniently is negative 2. So we're looking for the area from negative 2 standard deviations to the left of the mean to 1 standard deviation to the left of the mean. And that, I'm remembering back on the curve, is 13.5 plus the 34 up to the middle, and then the 34 to the right of the middle, and that all adds up to 81.5. Now with the same numbers for mean and standard, we're going to look at the area between 21 and 31.6. Well, the z-score for 31.6 is 31.6 minus 21 over 5.3, which is 10.6 over 5.3. And the z-score for 21 is just 0, because that is the mean. So we're actually looking for the area from the mean to 2 standards above, which is the 34% to the right of the middle plus the 13.5% to the right of that, which adds up to 47.5. Now on 22 with different numbers now, if the mean is 2 and the standard deviation is 0.05, find the percentage under the curve for more than 1.9. So a z-score for 1.9 is 1.9 minus 2 over 0.05, and that turns out to be negative 0.10 over 0.05, or negative 2. So we're going to do this from then negative 2 sigma to really just the right half, and I'm calling that 4 sigma, but we could, we're going to be 50% on the right half anyway. So the left part of it is 13.5 plus 34 plus 50%, the whole right half, because we're going greater or to the right of negative 2 standard deviations. And that's again 97.5%. And they're saying how many numbers would we get out if we had 20 numbers, and 97.5% would be 0.975 times 20, or 19.5, and so the number of values that we would get out of 20 would be 19 or 20. Now from 24, using the same numbers, we're going from 2 to 2.1. Now remember, 2 is the mean, and 2.1, the z number, is 2.1 minus 2 over 0.05, which is 0.10 over 0.05, which is 2 standard deviations above. So to the right of the mean, the first block is 34, the next is 13.5, adding up to 47.5. And so using the same thing we did before, what would be the chance of 47.5% out of 20 numbers, or 20 times, and that would be 0.475 times 20, or 9.5, which we would count as 9 or 10. Now the last one is mean equals 6.62, standard equals 0.04, and we want the area under the curve from 0.7 to 0.74. So for the high one, we have 0.74 minus 0.62 over 0.04, which is 0.12 over 0.04, which is 3 standard deviations to the right. And the low number is 0.7 minus 0.62 over 0.4, which is 0.08 over 0.04, which is 2 standard deviations to the right. So we're going from 2 standard deviations to 3 standard deviations, and that little bit is 2.35%. So if there were 85 trials of this, 0.0235 would be the decimal for that percentage, times 85 would give us 2 things happening. Now this is the end of our third week, and at the third week, all of chapter 13 is due. That included 13.1 and 13.2, which not all of you turned in last Friday, but now make sure that you get within, with everything you can do, get in 13.1, 13.2, 13.3, 13.4, 13.5, and 13.7. And then we'll be ready to do the review for the test next Monday. But we will only have a 4-day week next week. But God bless you, keep up the good work, and I'm really proud of how well you're doing. You're doing awesome, and I miss you guys a lot, and I love you very much. Have a great weekend.